Hello, and welcome back to the Tech Data Cyber Range Cyber Essentials series. This is course number 4, where we will move beyond basic commands and operating system fundamentals and begin to dive into security tools. Today we will be covering Network Mapper, better known as Nmap. In this lesson, we will learn how to use an open source network scanning tool to discover hosts and services on a network by sending specially crafted packets to fingerprint them. To further outline today's lesson, we're going to cover what is Nmap, what are ports and services. We'll discuss the differences between TCP and UDP, and finally we will go over some basic Nmap scans. So what is Nmap? Network Mapper, better known as Nmap, is a free and open source network security scanner used to discover hosts and services on a computer network by sending packets and analyzing the responses. It provides several features for probing computer networks, including host discovery and service and operating system detection. It has enumeration scripts called the Nmap scripting engine, which are specialized scripts to reveal additional information from the host responses to scans. Every host on a network has what's called an IP address. IP addresses are broken into two main groups, public and private. Private addresses are not routable on the public internet, whereas public IP addresses are. Most organizations leverage what is known as the IPv4 version of the protocol. These addresses are made up of 4 octets of numbers separated by a dot, for example, 1.2.3.4. As the IPv4 address space is run out, some organizations are migrating to IPv6. However, IPv6 is substantially more complex and is beyond the scope of this presentation. Every host that has an IP address will have an application or service running on it. Those applications will listen on ports, which make the application available to other hosts on the network or other networks. There are a total of 65,535 ports available for both TCP and UDP, which we'll discuss in part on the next slide. For example, port 80 is the service port for HTTP, which is the backbone of the World Wide Web. However, HTTP is not encrypted, so for websites like Amazon that rely on e-commerce, they host their site on port 443, which leverages encryption over HTTP, also known as HTTPS. So TCP, or the Transmission Control Protocol, is a quote, reliable internet connection similar to what you would experience on a phone call. The client initiates the call, the server answers, a conversation takes place, and finally the two parties hang up. There's obviously more to it on a technical level, but this is the high-level overview of how it works. UDP, on the other hand, also known as the User Datagram Protocol, is like a radio broadcast. The server simply broadcasts its packets, but the receipt of those packets is not acknowledged by the client, so there's no guarantee of delivery. This type of traffic is best suited for lossy communications, such as video streaming on Netflix or YouTube. Now we'll move on to Nmap. We will start with the most basic of Nmap scans, which consists of simply typing Nmap and then the target name. By default, this will perform what's called a TCP SYN scan. The target can either be an IP address or a domain name. Nmap will also only scan the most common 1,000 ports by default. And as you can see from our example, when we scan this domain, it detected 4 open ports on the target. Nmap allows you to define which ports you wish to scan. In our first example here, we tell Nmap to scan a range of ports, in this case, ports 1 to 10,000. We do this by typing nmap-p and then 1-10,000 and then the target. The second example shows Nmap only scanning specific ports, in this case ports 22 and 80. This is accomplished by typing a comma-separated list of port numbers after the -p flag. As mentioned before, Nmap only scans TCP by default. A commonly overlooked yet incredibly important part of host and network enumeration is to scan for open UDP ports and services. This can be done in Nmap by using the -SU flag. As we can see in this example, when we rescanned our target with that flag, we discovered an additional open port, port 123, also known as NTP or the Network Time Protocol. We could then infer that this host is also running an NTP server. After we have discovered open ports, in many cases, we will want to know more information about the services running on those ports. To accomplish this, we can do service version enumeration with Nmap using the -SV flag. In this example, we see not only is port 22 open, but it's running OpenSSH version 6.6.1, and on the OpenHTTP port 80, it's running Apache version 2.4.7. Beyond enumerating ports and services on the host, Nmap has the ability to discover what operating system is running on the target. This is accomplished by using the -O flag. As seen in this example, Nmap only provides a best guess as to the operating system and is not always 100% reliable. So putting it all together, Nmap has the ability to combine options to create more complex scans. You can also output the results of your scan to a file for later viewing. In this example, we're running Nmap with 3 levels of verbosity, which will give us more detail about the scan progress as it's running. The -P- flag tells Nmap to scan all 65,535 ports. -SV, as we mentioned before, tells Nmap to do service enumeration. The -SC flag runs all of the Nmap default scripts. For more information about what these scripts are, we recommend reviewing the Nmap man page. -PN tells Nmap not to ping the host and just assume it's up and go ahead and scan it. -A not only does default Nmap scripts, but it also performs OS or operating system enumeration, as well as run a trace route against the target. Next, we give it the target, and then with the -OX flag, we tell Nmap to output the file in XML format, and then last but not least, we actually give it the name of the file we want it to output to. So that covers the most basic elements of using Nmap. With that said, there's tons of information online showing further use of Nmap. We highly recommend checking out these links and doing more research and experimentation in your own home lab. So getting comfortable with Nmap is a key skill for any network security professional. Thank you for watching this week's training, and we will see you guys next time.